I'm gonna go ahead and mute. That way you can go ahead and do your intro and all that.
Yeah, it's fine. We're already live. So, hello, audience. As you might have already heard, I have with me today Shinobi 333 for the second time. The first time about, I think, 6 weeks ago, maybe. On the non sequitur, we had some severe technical difficulties. So, we're just gonna try to repeat this entire thing here, maybe without those this time. So, hello, Shinobi.
Hey, how's it going, bro? How's it going?
Thanks. And you yourself?
I'm sorry, what's that?
How are you going? What's
Oh, I'm
up?
pretty good, man. I just got home from work and for real, just got out of the shower, so I'm feeling
Okay.
refreshed. That's for sure.
Okay, and we also have a second guest who I haven't talked to yet.
Yeah, that's Trigger, and these are all my people that wanted to pretty much, maybe put their.
Hey, what up? What up? All y'all
Hello.
out there. How y'all
So,
doing today? I hope y'all enjoy the show. You know, we here to make we here to change minds and build positivity. You know what I'm saying? That shit lasts forever.
so one thing, Shinobi, I specifically asked you before we
Oh,
started this for a 1 versus 1.
That shit lasts forever.
yeah. Well, the thing is, okay, yeah. Just now when I shared the link, you told me that after I had already shared it about
Oh
sharing the
dear.
link. Like literally, I had already sent it out right before you were like, "Hey, don't share the link." But I didn't think you
Yeah,
would
well,
mind.
don't do that, obviously.
Well, I didn't do it like anywhere,
Yeah,
where
that
someone
doesn't
bad would
really
get all.
matter.
But no,
Hey, so
We can stay
let's just
quiet.
get right into it. Let's just get right into it because our
yep.
focus it seems like it's going somewhere it shouldn't right now. All right. What's your name is Geo? Okay.
Yeah, my name is Gio, but you can
How
also
you
call me
doing, Miss?
anyway.
How you doing, Mr. Geo? I got a question for you. Are you a globe earther?
Yes.
Um, can I ask you why?
Sure.
All right, so why?
Because all the evidence that has been presented and that is currently still being done and still being repeated points towards the Earth being a globe.
Okay, so what do you deem to be evidence?
What do I deem to be evidence?
Correct.
Well, would you like to go over specific points, or in general, what I suppose, or what I think would be considered good evidence in general? Like, what criteria does evidence have to fulfill to be counted as good evidence, or do you want me to list specific points?
Well, that would be all up to you. I simply asked you, what do you deem to be evidence? So that will mean anything that you deem to be evidential to your claim
Yeah,
to believe
okay.
that the Earth is globe.
So, for example, are you familiar with the pole star conundrum?
Say that again.
The pole star conundrum.
Pole star conundrum.
Yeah.
As far as
You know,
like,
the fact that we on the Earth we have two pole stars, or two celestial poles, one over the southern hemisphere, one over the northern
right,
hemisphere.
right. No, we get that. Yeah, the two poles and everything.
All right, and
What
you
about
understand you do understand the geometrical
Hold on.
impossibility of that over a flat surface.
Hold on.
Surface.
Where is your proof that there is two poles?
I live on the northern hemisphere. I can see one. Ask anybody who lives on the southern hemisphere: Australia, South Africa, South America. That's pretty much it. Ask them; they will say they will see one. It's rotating in the other way around, and the constellations they can see are different ones.
Oh, really?
If you seriously claim that
So
there are
I would like to know,
no two pole stars,
what are the
then you have a
names?
serious problem.
What are the names of the southern hemisphere constellations?
Directly around the southern pole?
What are the names of them?
Yeah, I asked for clarification. Are you talking about
I
the ones
mean,
direct?
obviously, there's only one set of constellations on the southern hemisphere. You seem to differentiate those constellations from the ones above the northern hemisphere. So
Yeah,
if you
obviously.
already differentiate those from them, that means you already include that it's only one in the southern hemisphere. So that's the one I'm talking about.
No, I'm not saying there's only one constellation in the southern hemisphere.
No, only one set of constellations.
Well, yeah, obviously.
All right. So why would you be asking me what set of constellations?
But I think you didn't maybe understand my answer. What I'm saying is that the stars that they're seeing on the southern hemisphere around the southern celestial pole are not the stars that are seen around the northern celestial pole. Therefore, they are two different celestial poles.
How do you know that those are two different ones and they're not the same one?
You could take a look at the individual stars. You know,
How do you know
the
you're not
constellations
just how do you know you're not just further away?
How do I know that I'm not farther away? Because the physical characteristics of the stars are different.
Have you ever been to the southern hemisphere?
I have not, no.
Me either. But I guarantee you the first time I do.
In the southern hemisphere than we see in the northern. That's kind of what I got.
You realize that what? You realize that when I speak now, okay? You realize that when you're on the southern hemisphere and you're taking a look at the southern celestial pole, you're facing southwards, right? Not northwards. When you're on the northern hemisphere, you have to face north to take a look at the northern celestial pole. However, when you're on the southern hemisphere, you're taking a look at the southern celestial pole, and you have to be facing south. Therefore, geometric.
Hold on.
Can you do me a favor and not speak every time I'm mid-sentence? Isn't that too hard?
Go ahead.
Therefore, there's a geometrical impossibility here. You cannot claim that the northern celestial pole can be seen from the southern hemisphere while it's in the opposite direction. There's a geometrical impossibility here. That's not physically possible.
Are you ready for me to respond to that?
Yeah, go ahead.
Okay. It will be geometrically wrong if your world was indeed a ball. But
I'm calling bullshit on that.
Hold on. Let me finish.
Sorry.
If
continue, please.
Your world was not a ball and simply a flat frontier, plain, plateau, however you want to look at it, with water on it, and you would look at it different, you wouldn't even think about a South Pole because there is no South Pole. There's only one pole. There's only one magnetic point on the Earth, and that's the North Pole. And there is no South Pole. They invented the South Pole to support their lie claiming the Earth is a globe. That's how that works. If you create a lie, you have to create many lies to support it, correct? Because you have curious minds. You have curious minds that are going to piece your shit down to size, and they're going to say this shit does not make sense. And that's what's happening right now. That's what's happening right now in our generation, bro. So I'm gonna mute my mic and I'm gonna let you try to explain what your perception is.
You're wrong on several points here. First of all, you seem to be mixing up the geographical poles of the planet with the magnetic poles. You realize that the northern magnetic pole is not on the northern geographic pole. They're about, I don't know, 5 degrees or so apart. Second of all, again, would you like me to draw this?
No.
To show you how this works geometrically on a sphere while it's not working geometrically on the plane.
No. You don't have to. I'm smart enough to understand how shapes work. So I don't need you to show me I don't need you to show me how a ball works. I need you to explain how you came to the conclusion to actually firmly believing that you live on a big ass ball spinning fast as hell, and it's also spiraling in midair in nothing. If you really could actually believe that, but you can't even consider the fact that it's all a lie, then that's the danger in what we talk about. Now I'm gonna mute my mic.
Okay, can you do me a favor and take a look at my screen that I'm screen sharing right now?
It's all a lie, and that's the danger.
And please do me a favor and mute the audio in the back because I can hear echo.
My bad.
So yeah, you're showing me measurements, which is totally useless in this conversation, to be honest. Unless the other guys are interested, I'm not gonna speak for everybody because I don't want to do that.
Honestly,
myself.
Honestly,
my
I'm not really
okay.
interested in your opinion right now because I was scheduled to talk to Shinobi, not to you.
Well, so I got a question for you too. Why did Admiral Byrd find land
Oh, for
beyond
fuck's
the
sake.
South?
Can we please stay at one topic at a time?
Okay,
All right,
so
go
your
ahead and
topic
finish.
was aimed at me. Your topic was aimed at me, so it's only right for me to end the conversation. Do you agree or not?
Not necessarily.
Okay,
We've started
so I
some.
guess well, okay, well, well, maybe you should formally allow somebody else to speak about something else. You know what I'm
Well,
saying?
we started.
Or be,
You do me a favor. We started
Topical.
a conversation now, and first of all, since this is my hangout, I decide now to answer this. You said that any measurements on the surface of the planet would be useless. Now, when you take a look at the diagram that I've made, the red diagram, or the red line actually in this diagram, that describes the connection between your position on the surface of the planet compared to the angle of the northern celestial pole. As you see, as you're directly sitting on the North Pole, which is there, the angle of the northern celestial pole will be 90 degrees, obviously. And when you're on the equator, which is over there, the northern celestial pole, as well as the southern celestial pole, by the way, will be directly on the horizon, meaning at 0 degrees elevation. So, and what you get in on a sphere is a linear correlation, which you can nicely see here as this red line. However, on a flat surface, you will not get that. You will get a tangential, a geometric function, which will never, under any circumstances, however you change the diameter of the Earth, however you change the altitude of the North Star, whatever you do, you will not get the same values. You will not get the same function. This means that
okay.
the only one of the two can work at the same time. Now, the question is which one of those two is the one that you observe in reality? And we can easily prove that it's the red one, thereby
Neither
disproving the
one,
blue one.
because it's a computer
None of that
program.
makes
And I think my question, honestly, man, it was relevant to what we were talking about just because we were talking about the polls. And my question was, how did Admiral Byrd say that there's uh, land beyond the South Pole? That's not something I'm not really understanding.
Before we
Because
go
if
to
the
this,
South, if this, okay, what's that? Go ahead.
yeah, before we change the topic, I want to have this finished first, obviously.
All right,
I
man,
got
go
something
ahead.
to say about what you just said about that. If
Oh
you
dear.
all right, so
Okay,
this
wait.
is what I would like to say
I need
about
my
that.
geometry program.
No, this is what I would like to say about that. When people say flat Earth, a lot of people without the how should I say this? The patience to actually consider that. What they'll do is they'll picture a actual flat ass Earth with no mountains, no elevation points, no depressions, no valleys, no rivers, no streams. They'll just picture a flat ass Earth, and then they'll try to perceive the world as they look at it in that way, and then they'll just say, "Nah, that shit don't make sense." When if you really think about this shit for a minute, the Earth is not completely fucking flat like a table. All right. What I'm saying is, no matter where you look at, no matter where you look, if you outside and you look left and right and you at a high perspective or a low perspective, you're gonna see a flat line, which is represented by what we call the horizon. Period. Just like that flat line you see in the middle of your screen, that's going left to right. That's a flat line. You know what I'm saying? So you may have mountains, buildings, and all kind of elevation points that may confuse the average person who's first of all creating maps. It'll confuse a motherfucker on how to map out certain things because why they're not looking at it from an aerial perspective. If you look at things from an aerial perspective, you will see things a whole lot different. And that's what they figured out back in 1943, when August Picard took a fucking helium balloon to the heliosphere, and he was the first person to do it back all them years ago. They don't teach you that in
Heliosphere.
school. They don't hold on. They don't teach you that in school because what happened was August Picard was the first crazy man. They said, "Hey, let's see how high you can go. You can make balloons float as high as they that damn high. You want to go up there and see what the fuck you can see?" The government paid for him to do it, and he took his crazy ass up there, and he brought his ass back down and told them what he saw. And that right there sparked missions for them to send pilots to the outer rim, the outer perimeter of our ecosystem, to find out what the fuck August Picard was talking about. Because when he took his ass up there, he told them that he saw the world and it was in a circle, like a plate. All right. And it was water around our nations that we know it today. It was water all around our nations. And around the water was a big ass ice barrier. And it looked like a plate with turned up edges. So what I'm here to tell you is, after that, they sparked a lot of motherfucking missions for pilots to go explore outside of the outer perimeter. All right, so that should ring a bell about Amelia Earhart and who did y'all just brought up? Somebody, Admiral Byrd, all of those people. All right, paid by the government. Now check this out. Later on, they established NASA.
Can you do me a favor and stop with your incoherent ramblings?
Look, I'm trying to get you to follow the perspective. That's the problem with globe earthers. They think in an enclosed type of way. That's why the globe deception is so fucking powerful, because it really got so many people to just think so goddamn linearly. They can't think multi. You can't think on multiple points and put them together. That shit is detrimental. Like,
can you do me a favor and please be quiet for just 1 minute?
Yeah, man, I'm gonna respect your panel,
you cannot simply continue rambling on without giving me any.
Panel, bro. I ain't hating. It's your panel, bro.
Okay.
Do what you gotta do. I'm about to smoke my blunt. Shit.
Because you guys have the tendency to run for everlasting rants.
Hey man, somebody else school this man, bro. I'm done, bro.
I mean, I still have the same question.
I just want you to prove a core, bro.
Like, proof of what?
Man, he can't even prove I'm wrong. Hold up. He can't even prove I'm wrong. Period. He can't even prove I'm wrong. He can't. All he gonna do is complain
prove you're
about,
wrong about what? You haven't made any argument yet.
I've already tried.
You haven't made any argument yet.
Like,
you know. Shinobi. So let's do it the way that I wanted in the beginning. I'll just kick everybody else to have the 1 versus 1, okay?
All right, let's do it.
Okay.
And I thought originally said
because as I said, it's getting too complicated the more people are in here. And you just witnessed why I don't actually like doing this. So last time on the Non Sequitur show, you had a bunch of questions which I couldn't answer back then for the simple reason that the video setup that I was using in combination with the video stream setup that the Non Sequitur show was using. How many people did you invite in here?
I didn't really make out that last part there.
Oh, for crying out loud. Again, I couldn't answer those questions last time because the video broadcasting system that the Non Sequitur show guys had did not work for server reasons or whatever. So one question you had back then was, why doesn't the moon cause a solar eclipse every time it travels around the Earth? So why isn't there a solar eclipse every month? I've actually taken the time to model this completely. So when you take a look at my screen, please, you should be able to see this neat little mathematical program that I have. Can you see my screen?
Give me one. Here. No, I cannot. Are you screen sharing on
I am screen sharing.
YouTube as well?
You should be able to see it. It's being streamed to YouTube.
Well, I'll put it up on my computer. Okay, loading. I got a slow computer, man. Okay, now I see it.
Okay, now you see it. So this is a mathematical program. It's called GeoGebra, or however that's pronounced. Oh, for fuck's sake.
Who's that?
I don't know. You tell me.
Oh, copper colored?
Yeah.
Yeah, I know him.
Yeah,
I put the link in there.
Please don't invite any people to my stream that I don't know, because they could pretty much snipe me directly.
Man, we don't do that shit, bro. All we want is the truth.
I cannot know that, right?
Right, you're right. You can't.
Okay, so again, back to my model here. This is actually a 2-scale model of the Earth, Sun, Moon system. So when I zoom out of this, you will see that on the left side of this model, I've set the Sun, and the zooming will take a while, unfortunately. So the Sun's over there. I could zoom back in there, but that's not necessarily relevant part here. And over here, I've got the Earth, which is this blue circle over here, and the Moon over there. Now, I have the ability in this model to actually change the parameters of the system, meaning I can change the Earth-Moon system, the Earth-Moon distance, sorry. I can change the Earth-Moon distance, I can change the Earth-Sun distance, and I can also change the angle in which the Moon is tilted above/below the ecliptic. Now, do you see those yellow/orange lines?
Yes.
Okay. Those orange lines represent the shadow that the Moon is casting through space. Okay. Now, what I can do with this, you see I have these 3 little levers over here on the top left end. What I can do with those is I can pretty much change the position of the entire thing. So you know that, for example, the Earth's orbit is slightly elliptical, and so is the orbit of the Moon. Now, those are actually the values. So this is in 1,000 kilometers. So this value 147,055 stands for 147 million kilometers. So I can change the position of the Earth, can move it left to right, and I can change the distance from the Moon to the Earth. And as you can see, I can also change the angle in which the Moon is behaving below/above the ecliptic. Now, as I said, the yellow lines, those stand for the shadow that the Moon is casting. Now, the relevant part of those two, that's the 2 in the center. Do you see those 2 lines? My mouse cursor is currently pointing at them.
Yep.
Do you see them? Okay.
Yeah. It takes me a minute because I'm watching it on YouTube, so there's a slight lag.
Oh, you're watching it at YouTube. Okay. Basically, I can change the Moon's position in its orbit. Right? When it's angled maximum towards the ecliptic, it is down here, and at its maximum, it's here. So the Moon can be between one of those 2 positions when it comes to being at the new Moon position, meaning that it's somewhere between the Earth and the Sun. Now, a solar eclipse only happens when one of those 4 light rays that I've drawn over here actually meets the planet. So when we slightly move the Moon down, in this case, we would get a partial eclipse now. Oh, wait, actually, there we go, that's better. We would get a partial eclipse now. We would get a total solar eclipse now, and a partial eclipse again, and non-eclipse whatsoever. So this shows quite nicely that we don't expect the Moon to cast a shadow on the surface of the planet every time it circles around the planet. Do you understand that?
Okay, well, I got 2 problems I have with it is one, why the real question I was trying to ask back then is why NASA had it that depicted as they did. Yes, I understand the Moon is not directly aligned with the Earth and it's above it. I understand that, but my question back then was why did they then, show it like that? But now my question,
simplification purposes, I guess.
Well, that's the thing. You guess. You don't really, have it's kind of silly for them to fucking, make us guess like that. But another thing is, you're trying to show me shit in the sky on this computer, little program, to me that just, I get that, you guys think that there's a space and that you have these programs that can simulate that, but the thing is that just doesn't validate it for me.
Well, first of all, I wrote this program myself. So not the program itself, but the content of this model, I did that myself according to the globe model, right? So this is one of the ways that it's easy to demonstrate on what we actually expect to see on the model. Don't worry, I will try a flat Earth model later. So we're gonna go for that as well. Why is it relevant what NASA says? I mean, the model is independent of whether NASA exists or not, isn't it? It did exist before NASA existed. You're aware of this, right?
What are you asking?
You're aware that whether NASA exists or not, the model is still valid, and it did exist before NASA existed.
Oh, yeah. No, I understand that the globe idea and heliocentrism, yes, I understand that began long before NASA. My problem with NASA is, and that's kind of what I was trying to express to you last time, dude, is that, obviously you're well versed in science and different, fields that science encompasses. Well, my point is,
yeah. Your point is?
Can you hear me? Okay, there you go.
I think you just
my
muted
point
yourself
is,
accidentally. Go ahead.
What'd you say?
Go
Okay,
ahead.
there you go. I can hear you good. Okay, my point is this: is basically, if you're looking from a historical standpoint, we've been lied to our whole lives. So, with someone lying to you, why would I only like nitpick? Like, why would I just think they're telling the truth on this thing? Like, why do they pick and choose?
Why do you think NASA is lying on something? Let me ask the question differently. What do you think the globe earthers in general are lying about?
Well, okay.
Let's just address that directly.
This is what I think. A couple different things. The main two being that one, they're hiding free energy from us, and two, they're hiding the fact that our world expands much bigger than what we've been told, and they're just kind of keeping parts of that sanctioned off, if you will.
Okay, so let's just start with the first one, I guess. Free energy. What do you expect free energy? Why do you think they're hiding something like free energy from us, and how would you define it? What do you think free energy is in the first place?
I mean, energy's all around you, man, but I think that like magnetism would definitely be along the lines I'm talking about, which I'm definitely no expert in whatsoever. I just know on a basic level of how it ties into like how pretty much everything is grown, how it like shapes its growth, like flowers, different flowers, fruits, everything. And so like that explains our reality much better, a lot better than all these like theories that haven't been proven. Like, are you aware of a? I'm sorry. Go ahead.
First of all, you have to define what you think energy is first, because you're mixing up a lot of different terms here.
Well, I mean, energy is like, there's different meanings. I mean, you got your scientific definition, I'm sure, which I definitely couldn't tell you off top of head.
Yeah, obviously we need to find one which, first of all, if you're not using the scientific definition of energy, in which energy is the ability of a system to do work.
Okay, how about
then you have to find another word for it, or make sure that you don't accidentally mix up the terms.
Well, let me ask you a question with a question. What is not energy?
What is not energy?
What is not energy?
Everything that doesn't fit that definition isn't energy.
I mean, what definition are we going off? Because my definition of energy is everything has energy. Like everything encompasses some kind of vibrational frequency.
Oh God, no. Okay. What do you think a frequency is? What do you think a vibration is? You're throwing around these terms without actually seeming to understand what they mean.
Well, it depends. I'm using terms that I'm trying to relate in modern day, but I'm speaking more towards on like ancient teachings of like pre-dynastic era, basically pre-dynastic ideals like heliocentrism, religion, with like male deities and all that shit. So pretty much the only thing I'm trying to express, man, is that there's a lot of deception that we've been told, that's obviously a fucking lie. Like you asked me earlier, what's NASA lying about? I can tell you a million or at least 100 things. I've got a bunch of videos of them using harnesses and saying they're in space and shit when they're clearly someone like slowed down the video clips that they're using, and you can see them fucking with the wires, and like one dude's in the background wearing a harness. It's like, I'm just not really sure why they're fucking lying to us like they are.
Okay, so let's just assume that NASA is full of shit, okay?
Okay.
Okay, and let's assume we have no measurements whatsoever about the shape of the planet.
Okay.
Okay, what methodology would you use to actually determine the shape of the planet?
Well, I would use my eyes, my senses.
Okay, and if you
Have
were
you ever?
able to, I mean, obviously, we are in agreement that you would be allowed to use more accurate instruments, telescopes, theodolites, that kind of thing.
Okay, sure, yeah.
Okay, so the question is, you're standing at this crossroad. You can decide that two, obviously there would be, in this situation, there would be various possibilities on the shape of the planet. What do you think would be the next step? The way you would handle this, in my opinion, is first of all, you ask yourself, are we able to actually determine the shape of the planet? Second of all, how do we do that? And the third question would be, which type of results would we expect for which possibility, right? Assuming that the Earth would be spherical, what type of data would we expect, for example, from measuring the distances, or for example, from measuring the angles between, as I said, for example, the North Star and your position on the planet, and the horizon? So what type of mathematical function would you expect in one instance with one assumed shape, and what mathematical function would you expect in another case with another shape? And that's pretty much what I'm doing with the diagram I was showing earlier. I assumed twice. In one case, I was assuming the Earth would be flat, and in the second case, I would assume that the Earth is spherical, which is what's giving me those two different nice diagrams, as the ones that I'm showing again, one being red, the other one being blue. Now, the next step would be to actually do the measurements, meaning to actually go in the field, take your theodolite, point it at the North Star, point it at the horizon, measure the angle between the two. Right? This is what you would do.
I wouldn't say I would. You're asking me if I would do what you're doing, basically.
Do what?
I wouldn't assume that. I wouldn't really even probably any type of round Earth or globe that we talk about. I wouldn't really assume that to even be a possibility if we didn't have people speaking on it otherwise.
Why? I mean, if you don't know anything about the properties of the planet, any shape in the beginning without having any data would be theoretically possible, or at least conceivable, right? So at least in order to exclude it, you would have to do an experiment to show that it's false. Right? This would be probably the easiest.
Yeah.
Determining
if you want to
that
find
a
out,
model is false
like
requires little work in this case. But yet you would have to model the model itself to determine what kind of results you would expect from that model, and then measure results that contradict that.
Okay.
Okay, so this is what we're doing. When you run the different possibilities, and then you actually check the numbers that you get in the field, you will find out that everything that you can possibly measure matches up with the globe model. and nothing matches with a flat Earth model.
Okay, so let me ask you this: do you know what a gravitron is?
Gravitron, right now, no.
It's it is actually they have them. I don't know about where you live, but they have like a
Yes,
little.
okay, I looked it up. Got it.
Okay, yeah.
It's
So
basically a bigger centrifuge
yeah,
in which
so
you put people. Yeah.
well, NASA says that proves gravity, right?
No. Everything a graviton proves is that centrifugal forces are a thing.
No, not a graviton. Not a graviton. Not the particles that make gravity.
Yes,
Is that
a
what you thought?
gravitron, a big no, a gravitron, a bigger centrifuge, which is an amusement ride park thing.
Yes, exactly.
Yes, that doesn't prove
So-
gravity. Whether gravity exists or not, a gravitron would work anyway.
Yeah, I was just asking why NASA says that's proving gravity does exist.
I will need a source for that. I think you're misquoting the source here.
The Space Center in Mississippi, or I think it's Alabama. I think it's either Mississippi or Alabama. Let me look at it. Let me look on YouTube. But anyway, it's a NASA Space Center, and they have like one of those deals. And when they tell kids that this is how gravity works, when they get on the ride, they have like a little astronaut that's in the middle, sitting there in the middle, controlling it and everything. So you even said it didn't work. I'm just wondering why they did. Or,
no,
I'm
saying that whether gravity is a thing or not, a gravitron would work anyway. Because the way a gravitron works is when you accelerate the object in question, in this case, a person, and as soon as it has a certain speed, or as soon as it has any speed, it wants to stay in a movement that is linear and that is in the direction it's currently moving. What the gravitron itself does is it's pulling, it's pushing, pulling. Yeah, let's say pulling. It's pulling the person inside the gravitron away from this linear course, which the person itself feels as an acceleration. This is the centrifugal force in this case. You feel that you're being pushed to the outside of the gravitron. However, this has literally nothing to do with gravity.
No, I understand that completely. My question was, why do they teach that at that NASA Space Center? And I know someone who learned that as a child. I was looking for the. I'll find it. I'll find the name for you.
Okay, so what you can do with a gravitron, obviously, is you can simulate high accelerations. So if you, for example, want to find out how the surface acceleration is on a different planet, you can simulate it this way. However, because if an acceleration comes from gravitational attraction or whether it comes from a centrifugal force, doesn't matter, you will feel it anyway. So you can use it to simulate gravity, but you cannot use it to explain gravity.
No, I completely agree with you.
Okay, so what's your point?
So my point was this: it does spin. If you were to put water in there, okay, per se, and spin it, do the same thing. Let's say at 1,000 miles per hour. What would the water do?
What do you mean by 1,000 miles per hour? Because when you take a look at the formulas that are relevant, what is actually interesting?
Well, I was just giving a speed, just like per se, like it's to relate to me. I use miles per hour. I live in America.
Yeah, I know, but we need angular velocity. We need rotations per minute or rotations per second, not miles per hour.
Okay, well, let me put it a different way. The fucking thing is spinning with water in it. It's going to do the same thing. The wall is going to keep it from flinging off.
Yeah,
so
but obviously the water is pulled to the outside and then sticks there.
Correct. So if our Earth is spinning, I'm really not understanding how water's not fucking flinging all willy-nilly.
That's easy. I can do the calculation live. Okay.
Well, yeah, you can do it on a computer, on a program. That's my big problem with all this.
Wait, stop. I'm using a computer right now because I cannot do the calculation by hand and show it to you, right?
Well,
the computer
no.
is currently only my notebook in such a way because I have to show this to you in a way that you can understand it. The calculation itself, it's completely irrelevant whether I do it on a computer or a tablet or on my hand or with my fucking Casio calculator or whatever. I can if you want me to honestly answer your question, then I need to show you the calculations that are relevant for this. Okay.
All right, proceed.
Okay. What we need is, in this instance, the centrifugal force. Let me just find the calculation, the formula. Omega divided by R squared divided by R. This one is fine, I guess. Okay, so this is the German Wikipedia article. The English one will contain the same formula. So let's take a look at this formula. This is the relevant one, okay? Let me open, I don't know, Word. I'll do the cheap way, I'll use Paint. Oh, this would be disgusting. Okay, so the formula is centrifugal force. This, because I'm using the German word centrifugal, which is written with a Z, I'm using it with a Z, okay? Doesn't make a difference. Is the mass of the object times omega squared times R. Okay?
Yep.
And the other one is the formula for gravitational attraction. I know that one by heart. It's Fg.
I'm not saying that you couldn't write them down. That's not my problem is it's an equation. It's based on really nothing. I mean,
yeah, it's based on observation. This is the second formula. Now, when you're claiming that the water should just fly off into space because the Earth is rotating, what you're claiming indirectly is that the centrifugal force should be bigger than the gravitational force on the surface of the planet. Okay? That's the thing, because when the force upwards, which would be the centrifugal force, is bigger than the gravitational force, which is going downwards, then obviously the net force will be pointing away from the surface of the planet, and therefore the water would be flying off. Right?
sure, yeah.
Okay. That means those we can actually calculate. We have the mass of the object. Actually, we can just cancel the mass. We can just rewrite this as an acceleration. So how do I do this here? There we go. So I can delete that. I can delete that. And I will replace the forces by accelerations. So that's supposed to be an A for acceleration. Okay, so what we need to compare is this term, is this bigger than this term? In which omega squared times R equal, well, omega is 2 pi divided by T, and R is the size, the diameter, the radius of the planet. That would be 6,371 kilometers. Obviously, we need it in meters. T is the rotational period of the planet. So that would be 24 hours times 60 minutes times 60 seconds. Okay. Now, when we plug this entire thing into the calculator, actually, let me get my calculator. So I'm now using my my Casio calculator. So let's see. Omega squared divided by. That's 2 pi divided by 24 times 60 times 60. Squared times 6371000. And we end out with a force being 0.0. Sorry, it's not a force, it's an acceleration. 337 meters per square second. Okay? This is the result that we get from the centrifugal acceleration. Okay? Now, to calculate the gravitational acceleration, which is heading downwards, we need the following values. We need big G, which is the gravitational constant. And this is, so G equals 6.67 times 10 to the minus 11 cubic meters divided by kilogram square seconds. This is one. And the other one is the mass of the Earth. So that's big M. That's 5.972 times 10 to the 24 kilograms. Okay, now, so when we plug in those numbers into that equation, we actually do this again. So we have the 6.67 times 10 to the minus 11 multiplied by 5.972 times 10 to the 24 divided by 6370, it's 1000 squared. And we end up with what I expected, 9.813 meters per square second. Okay. So you see that the gravitational acceleration which an object feels on the surface of the planet, on the equator, is much bigger by a factor of around 300 or so than the acceleration it feels due to the centrifugal force. So your claim that even when the Earth is spinning at the speed that we claim it's spinning, the water would fly off into space is factually incorrect. And the Earth would have to spin a bunch squared few times faster to actually cause this, like a few hundred times faster.
Yeah, I don't really see that as proof.
You don't really see that as proof. What would you see as proof?
Well,
wait a second.
I guess anything I could demonstrate on a micro level would be rejected by, you know, anybody who believes what you would believe.
Okay, so let's start the easy way. Do you have any problems with the formula for the centrifugal force?
I have a problem with any of those equations.
I mean, that one's very easy to test, right? Because you can build a carousel or a gravitron or whatever, and then directly measure the forces independence of the diameter of the centrifuge, the speed at which it's rotating, and the mass of the test object. Right? You would directly see that the force that is felt is directly proportional to the mass. Therefore, you can cancel that one out and directly get the acceleration. And the other two, that's just two tests you have to do to determine that. So I think that one is that's the easy one. The difficult one is the gravitational force. How do you determine the gravitational force, right? And
So,
I'm
okay,
pretty
can
sure
I
that.
quick?
Sure.
Would you agree that gravity, it being real, causes an apple to fall to the ground?
Yes.
Okay, well, why the hell is gravity so selective? Like, why is it
It's
not
not.
pulling all the apples down? It's not because the apple's ripe and ready to eat.
No, it's because in this case the connection between the apple and the tree has become weak, and therefore the force that the gravitational force is stronger than the force that's actually holding the apple up. All apples feel the attraction of gravity, but only the ones which have a connection to the tree, which is getting weak because the apple is getting ripe, are actually ripped out from the tree by it.
Well, yeah, I agree that it gets heavy because it gets ripe and ready to eat.
No, it's
But
heavy
I just don't
anyway.
see how that agrees, or I don't see how that proves gravity. Like, my question is like, why is gravity so selective?
I'm not saying that apples are proving gravity. I'm saying it's one example of gravity acting on things.
Yeah, no, I just asked if that gravity caused that. I know that's not like, I'm not saying you were saying apples prove gravity, but if if gravity is pulling all the water down,
Yes.
to the earth, I don't see how shit flies, like butterflies, birds. Like, why would gravity not pulling it down too?
Well, it is pulling them down. That's why we cannot fly, right? You have to have special aerodynamic properties to be able to counteract the force of gravity, which in this case would be the uplift by the wings of whatever thing.
Which I would agree with if gravity had been proven, but it's still a theory.
Yeah, everything is a theory. You understand that the meaning of theory in science is a little different than the colloquial term? Do you know what a scientific theory is?
Not like an exact definition of it.
Okay, let's Google that. So, scientific theory. Okay, can you see my screen?
Yep.
Okay, can you do me a favor and read the first sentence?
It's scientific theory is an.
Oh, wait, stop. Let me zoom in a little bit so you can read it better.
Yeah, I can't see it very well. Is an explanation of an aspect of the natural world that can be repeatedly tested and verified in accordance with the scientific method, using accepted protocols of observation, measurement, and evaluation of results.
Okay, and do me a favor and actually read the rest of the paragraph. So, starting here.
Okay.
Yeah, just read the rest of it.
I read it.
Okay, so the last sentence of this says that established scientific theories have withstood rigorous scrutiny and embody scientific knowledge. This means that when you're talking about a theory in science, you're not talking about a wild guess or anything. You're talking about something that you can actually demonstrate, which is why gravity, even though it's quote unquote still a theory, doesn't mean it hasn't been proven yet. Quite the opposite. If it hadn't been proven, it wouldn't be called the theory of gravity. It would be called a hypothesis.
My problem is I think they're using gravity as a name to actually cover something else up.
Do you concede that the point you made before is wrong then?
As far as
using the fact that gravity is a theory as an indication for it not being proven yet.
Yeah, I mean, I wouldn't say I agree with that, but I'll agree that science says that. Yeah, sure.
Okay. So what was the next point again?
So, I was wanting you to pull up a Ferricell. Do you know what that is?
No. Can you spell it or maybe write into the side chat?
Yes, it's I believe it's Ferroll, Ferrocell, magnetic, or magnetic field viewer.
Oh yes, okay. You mean one of?
I'm sure you know what that is, right?
Yeah, it's basically a bunch of ground on metal iron pieces that react to the magnetic field that you can use to show the magnetic field lines in space or in a 2D environment.
Can you screen share that at all? Because
I
I
mean
can't see it.
something like this.
Let me see. Are you on? Well, that right there is a little different than what I was talking about. It has a liquid inside with some like LED lights inside, and then you put the magnet on top of it, and then it reveals the magnetic field.
Something like
because
this.
of the special. This is that what that is? This one looks a little different.
I don't know. I think it's better if you find
Okay,
it on your
go
computer
down
and
on
just
YouTube.
send me the link.
Actually, I do have a picture of it. Let me go to my back chat real quick. Bear with me here. Okay.
Are you maybe talking about ferrofluids?
Yes, I think that is the.
Well, a ferrofluid is pretty much only the liquid form of what I just showed you, right?
Yeah,
The
I
small
believe so.
ferromagnetic material pieces are embedded inside the fluid instead of just being solid or being like powdery.
Well, my point, I was trying to get a certain image of one to pretty much show you like the magnetic field, and then I was going to relate that to a lot of things in nature.
Yeah,
So I'm
I
trying
know
to
how a
find.
magnetic field looks like.
Yeah. So actually, I found it. Here you go. Let me save this. I can't
Just
copy it.
copy paste the link in the side chat so I can open it here.
Let's see. Few details. All right, I'm gonna have to go online and get it. I can't do it from my chat. Okay. I'm having to go on Google real quick and get the link.
Take your time.
All right.
I just don't understand on why you changed the topic from gravity to magnetism.
Well, because I believe that that's the force that controls this realm.
Well, no. At
And
least, no. No, definitely not.
at least how everything grows. I can that's what I'm trying to prove right now.
How
Let me,
everything grows.
yeah, if you go on Google for me, man. Just all you got to do is type in the Ferrocell magnetic viewer images, and let me get back to your call so I can see your screen. Okay. Are you not screen sharing?
I am screen sharing.
There you go. Yeah, I can see your desktop.
Yeah, wait. Ferrocell magnetic what?
And then viewer, Ferrocell magnetic field viewer. That would probably work though. And then go to images.
Yeah, the same thing that I had before.
Okay, keep going down a little bit. There's a specific one I'm trying to show you because I wanted to relate it to some other things. Keep going. Can you go down a little more, please?
I'm slowly scrolling down.
Oh, okay. It's just lagging or something. That's fucked up, dude. It's not even popping up on yours. All right, let me do this. Since it is on mine, I'm just going to search it on my phone. And then I'll copy that link and send that in the chat.
Oh, wait, apparently somebody just Skyped it. Is it maybe this one?
Let me see your screen.
Wait.
Nope, that is not it either. Sorry. It's actually a circular. For the magnet is in the middle of the ferrocell, and it's projecting a toroidal field essentially, like a top view of it. If you were looking at the top perspective of the hyperboloid, as opposed to like a side angle of the view or whatever.
Are you talking about one of those?
I can't see your screen.
I'm screen sharing.
Okay, yeah, that's more on point with what I was saying.
Well, the only difference is the shape of the magnetic field, right?
Yeah, instead of 4 of them like you got there, it's 1, where that's making 4 different fields. This
Something
one
like
is
that.
just 1. Let's see. All right, sure, we'll go with that one. That's close enough.
Okay.
And now Google sacred geometry.
Oh God, no! Don't do that to me.
Come on, man, do it. Humor me. Sacred geometry
I know.
in plants, in nature. Put in nature.
This is gonna be painful.
You can't tell me though. Come on, man.
You can tell me that. Come on, man. I don't understand your point.
You're telling me that does not look exactly like what we just saw.
First of all, no. Second of all, even if it did, you have to actually demonstrate a causation between the two.
No, my point is that everything grows. A magnetic field is literally the force behind how things grow, how our nature works. This is a macro level right here of viewing.
Yeah, but
if you wanted a micro level,
you need to prove
micro.
this. You need to prove this. Just comparing the shapes doesn't do it.
I just showed you a magnetic field that literally looks just like everything you're seeing right here. I mean, I don't.
Yeah, and you picked that specific magnetic field over the other ones I showed you before because those ones don't align with what you see here.
Well, no. Those ones align with I'm sure other things too. Just this particular one, yes, I picked it because it relates to these images that you see right here. Now, if you were to show me some more, I can relate them to other things, but this is just basically all to simplify it.
You realize this is also not how a magnetic field looks like, right?
Well, I mean,
so okay, let's start with this first.
So.
You realize that the viewing screen you have here, this magnetic screen that contains the magnetic particles that align themselves to the magnetic field. That's first of all, that's only 2D space. So you're getting a 2D representation of something that's actually 3-dimensional. Yeah, that's fair enough to say.
If you had okay, go ahead.
So if you turn and twist it at some point, you will superficially get it to look somewhat similar, yet you're still not having something similar.
You're seeing different angles of the magnetic field by
exactly.
moving it around.
So yeah, and even when it's aligned correctly, it's not what you see with the plants. And even if it was, then again, still you need to demonstrate causation between the two. You need to demonstrate that the magnetic field has in somewhat of a way an influence on the plants. For example, by putting a plant inside a magnetic field with a different shape and then seeing how the plant grows and seeing if it has any influence on it whatsoever, which it doesn't.
I mean, visual proof is pretty solid to me, man. That definitely doesn't grow, it grows in a particular intricate pattern for a reason. It's not
Yeah, but if you're saying that magnetism is the cause of this, you said earlier that I tried to quote you here that magnetism is the force that
I
dominates
wouldn't
our
say it's
realm or
like
something.
I wouldn't say
Um,
it's like go ahead.
yeah, if you're saying that magnetism is causing this, then the way to demonstrate this would be to grow plants in environments where there's a strong magnetic field with a specific shape, and then compare those plants to the ones that grow naturally outside and see if there's any change. And there isn't any. I mean, there isn't anything demonstrated there. You literally have no point.
So you're telling me that you've done this research and
No.
you're basically
I'm saying that if you're claiming this, then it's your job to do the research, and you haven't. So
well, I know having
until
done
you
that
show
part is
any
right.
correlation or any causation between the two, I'll just go with Hitchens razor by default and say that the that since you haven't provided any evidence, I can just reject your claim without providing any evidence for that.
No, I mean, yeah, and that's your choice to do so. I think that for me to even talk about my stance would really be a waste of time. With considering who your audience, is not very in tune with what I would call the natural world. So,
Well,
um,
are you sure about that? I mean, we literally have a biologist in the audience. You can get more connected to the natural world than a biologist. And I wouldn't be surprised if a good friend of mine who's a physicist is watching this as well.
well, I mean, I'm just saying, dude, like, I really don't see the point in continuing the conversation. Because at the end of the day, like, if you don't want to believe what I'm telling you, that's fine, dude. It's helping me out, and
Well,
I see the truth.
isn't that an admission in a way that the only thing that could convince me to actually accept your position is to believe in it, which means that you have no substantial evidence slash no evidence slash no piece of data
No, I
that
showed you
points to your
my
conclusion
evidence,
in any
man.
way,
I showed you the evidence.
which
You even
is
agree.
completely non-conclusive, yet not even available since you haven't done any tests to confirm that.
My test is I can visually see the similarities, and it's no coincidence that they look to the fucking T
Stop.
one on like
You're saying
one.
that
I
it's
mean,
not a coincidence. How do you show that it's not a coincidence?
by looking at it, it's the same thing. It's the same exact thing, dude.
But you are claiming as a fact that it's not a coincidence. You cannot say that it's not a coincidence without actually proving that it's not a coincidence. It still can
Is a
be a coincidence, right?
a term like what is a coincidence? What exactly is a coincidence?
That's when
Chance, is that how
two
you define it?
correlating phenomena appear, even though the probability for those appearing is significantly low or something. I don't know the exact definition for it.
Well, I'm just saying, man, to me, they're they look, I mean, identical, man, to the T. There's no distinguishment between the two. And I understand that, yes,
No, they don't. You can see the difference between the two.
I disagree with that.
Oh, dear. Second of all, again, you have no control whatsoever. You haven't done any tests in which you try to manipulate the plant growth depending on the magnetic field outside. Right?
Yeah, no,
when
you're
you
right.
could do that,
You
and when
are
you could
absolutely
demonstrate
right.
that there's a correlation there, then maybe you would have a point. But right now you don't have anything.
That's honestly not bad advice. That is a good idea. I should do
Here
that.
is my prognosis. It won't change a goddamn thing. You will likely see no change in plant growth
It's not
whatsoever,
necessarily.
depending on whether there's a magnetic field around it or not.
Hmm.
Right? I mean, you understand my point that I cannot accept your position without you providing any significant evidence. And so far, you haven't.
You don't want to take that as significant evidence. Evidence, that's fine.
Well, just
like
comparing shapes
me,
doesn't do, obviously, right?
for you, it doesn't, obviously, no.
Well, then your standard for what counts as evidence or not is extremely subjective and extremely, what's the right word for this? Selective to whether I provide something like, as I did before, the different angle values and the size of the solar eclipses we were talking about, compared to your evidence when you just say, yeah, the shapes match, therefore it's proven, right?
Well, I'm
You cannot
showing you
apply
real
one. You
stuff,
cannot apply
man.
one standard
I'm
of
showing you
evidence
a
for
real
me.
magnetic field, real sacred geometrical shapes that are formed in nature, like real shit. I didn't, I can go probably find a pine cone outside and take a picture of it if you want something that I can actually tangibly give you. But you can't compare that to what you showed me, man. You didn't show me anything real. You showed me a computer program with which you can.
I showed you a computer program, but the data I was putting into that program was founded directly in the model.
But you
right?
did not. Okay, if you're gonna go off of what you just told me, then I can say that to you, and that you're going off a bunch of hearsay that came from basically the scientific giants or whatever the hell you'd call them before you. So you're relying on all their information.
What exactly do you want me to prove? Of course, I'm using their data sets and the formulas that they have derived, because I simply don't have the time to do it myself. Otherwise, we wouldn't have any progress whatsoever, right? The same way that I'm using chemistry, chemical reactions that have been developed in the last few centuries is the same what I'm doing here in physics. I can rely on their reliability because they've been used over the last few decades at least, and they continue to deliver good results. So why should I not use them when they're available and they're reliable? Whether I do this in chemistry in my lab work every day, or whether I do this in physics to show you how water wouldn't be flying off the planet, doesn't make a difference.
All right. So can I ask you a question then? It's going to be not related to this. It's going to be changing the topic. Is that all right?
All right. It's okay. Go ahead.
So this is my question. You do agree that we, take journeys, or not we, but, astronauts take journeys into space, correct? You agree we've been to the moon? You do agree we've been to the moon, correct?
Yes.
Okay. My question is this: why can't we go through the Van Allen belt? Why does NASA say we can't go through it?
We can go through it. It's just not wise to stay there very long. Obviously, the radiation damage that is done to the radiation damage that's done to astronauts or to any technology being the radiation belt obviously is cumulative over time, meaning that the longer you stay in there, the better it gets for your health. When you just fly through them, it's pretty much okay, which was done. I think during the Apollo missions, they tried to avoid like the parts of the radiation belts where the radiation was the worst, and they didn't stay there very long, just a few hours, I guess.
It's funny you say that, because I've got a video clip from one of the astronauts on that mission, and he said they didn't even take the Van Allen belts into account. He's like,
probably because there's no reason to do so when you're just flying through them. As long as you don't stay in them, it's not too bad, at least when we're dealing with the radiation belts of the Earth.
Well, I'm just not understanding why NASA says we're still trying to figure out how to get through it then.
I need to see a quote on that.
I can find a video, actually.
Yeah, obviously you cannot share. Can you share your audio? Because I cannot with this setup.
What I'll do is let me get it on YouTube on my phone, and I'll send you the link, because I'll find this a lot quicker than I was trying to find that image there. But yes, it's I believe
Okay,
from
so
2018.
I get
What's that?
information from the side chat. So apparently the Apollo 11 mission had the astronauts only spend about 1 hour in the Van Allen radiation belt on the way to the moon.
Okay, I'm trying to find this. Okay, I've got, here we go. All right, let me copy this link. All right, shit. Can I email it to you, or is there? Oh, I can do it on Google, right? Because we didn't have a back chat.
You can email it to me if you want.
I found it. You should get this.
Via email or via Google?
You should have got it just now.
I don't see anything so far.
Okay, here, let me just email it then. All right, sending.
You really need a messenger or something. Skype, Discord, whatever. Ah, there's your mail.
You got it? Yeah, I don't
Okay.
know.
Timestamp?
Timestamp?
Yeah.
What do you mean?
The timestamp for the quote that you're citing.
The quote? Oh, timestamp. Sorry. Shit. It's only like 7 minutes long. Do you not want to
So,
watch the whole thing?
not really, no. I only need to know the specific quote. Because, for example, when they're talking about, like the question is, for example, are they talking about astronauts being in the Van Allen radiation belt, or are they talking about electronics? Which is obviously a different thing to do, right? Electronics
He
has
said
changed
that,
over the last 50 years rapidly compared to anything that changed
the
in human
quote that he said that I'm thinking of is that they cannot, they're still trying to figure out a way to get people past it because people can't go through it. That's what that video says.
And is that actually the quote from the NASA scientist?
That guy he's speaking for NASA. That's a NASA video.
Well, first of all, this is not a NASA video. This is a video of a flat earther.
The guy in the video, I mean.
The guy in the video is saying it. Okay, when is he saying it? Oh, yeah. Wait a second.
I mean, I'd have to. Let me see. Hold on.
They have already. Somebody was quick in the side chat. It's a 3 minute 10 seconds. So I take a look at that. Give me a second.
Damn.
Okay, they're talking about electronics. Do you understand how vast or how quickly electronics has changed in the last 50 years? Hello? Yeah.
From what they tell us, yes. Can you hear me?
From what they tell us, do you understand that literally the digital revolution that we've had since the 60s wouldn't be possible without the rapid change in electronics?
All this shit we have now, we've been having more advanced shit than they let us know, dude. Come on now.
Do you think that in the 60s we had fucking 7 nanometer processors?
I mean,
that's yes or no. Do you think that in, let's say, 1960, let's say 1970s, they had series mass-produced, let's say, 22 nanometer processors? Because 22 nanometers is a system that I'm currently using in my PC. Right? That's a 5-year-old or so machine.
I mean, I'm speaking about just technology in general. Like you're kind of picking one.
Yeah, we're not talking about technology in general. I'm addressing specifically what they are talking about in the video, which was what you challenged me to do.
Yeah, and I told you that it's been a lot more advanced than they've been telling us. They slowly leak it out so they can milk the fuck out of everybody. It's not that hard to.
So your claim is that they did have this technology back then.
I don't know about this specific technology that you're asking about.
So you cannot make the claim that they didn't. Okay. Have you ever seen a computer from the 1980s?
I've seen one that they've showed me a picture of.
Did you have, like, how old are you?
I was born in 90.
In 90, okay. Do you remember the good old, well, I was born in 93, okay? First computer I had was a Pentium 2 with like a 450 or so nanometer CPU, meaning that the smallest structures inside the CPU would be approximately 450 nanometers in size. Obviously, every single electronic part inside the CPU is shrinking, right? Because you need to squeeze more of them in the tiniest space to get more computing power.
This is the thing, man. I know that our technology was not as advanced back then to the public, but on a warfare level, the most advanced technology does not get put out to the public because it's used for warfare. Because whoever has the best technology can obviously has more weapons on their side to win wars, take shit over. So I don't get what's so hard to understand about that.
Okay, here's the thing. When you take a look at older computers, the immediate thing you notice is that their computing power goes down rapidly the older they get, right? In the 80s, we had 8-bit machines, which were comparatively crappy to even early Windows computers in the 90s. And if you go back one more decade, it will get even worse, right? In the 70s, computers were as big as refrigerators. In the 60s, they were as big as rooms. In the 50s, there weren't hardly any. In the 40s, there were practically none. Now, one thing about electronics, especially semiconductors, is that the smaller they get, the less external interference, for example, from irradiation they can stand. This means that the old technology they had in the 60s, that they had in the Apollo capsules, was actually better to withstand the irradiation in the Van Allen belts than what we have today. You have to actually harden the electronics against irradiation from high energy particles. And this is what this video is talking about, right? That with modern technology, we have it harder to actually withstand the irradiation inside the Van Allen belts. That's the point they're making.
Okay, well, what I was saying about the technology is, of course, things were progressive. Like, yeah, shit was not as technical back in the 70s, and it progressed upward for the fact that they could leak shit out slowly, give you the idea that, oh, things are changing, and they do it in such a way that, like, do you not know how much money you'd get from that, dude? Like, I don't know how much of a business mind you have, but yeah.
Are you talking about semiconductors?
About what?
Because I agree that when it comes to processing power, obviously that's a giant gold mine, but this has nothing to do with the fact that the change in technology is actually negative, or the progress in technology is negative when it comes to being hardened against radiation. Also, who the heck are you talking about? Are you talking about NASA? When you say they?
Well, no, NASA is like a finger on the hand, but it's not direct. It's not like they're the fucking head honcho of this shit. No, that's not what I'm saying.
Then what are you
If
saying?
you
Because I'm
really,
still trying to understand your point. You literally haven't made any points so far.
I don't see how that is because, I mean, how is that? Literally, what
How
have I
is
said?
that? Well, we were thinking. Well, in the beginning, we were scheduled to talk about flat Earth stuff, right? And one of the first things I said was assuming that NASA and ESA and Rocket Lab and SpaceX and all the other companies are full of shit, right?
Yeah.
That still doesn't change the fact that we can actually measure the shape of the planet. We can determine the shape of the planet without relying on companies. We can do this shit ourselves, which was what I was actually hoping to talk about. So my question to you, how would you determine whether the Earth is flat or a sphere?
Well, me personally, I would get up as high as I can, as high as I can go. But
Okay.
obviously, that doesn't really prove it until you get to a certain amount of feet, I would say, um, is what they say. But that's what I would do, though, to prove it. If it was just
Okay.
me.
So what would you expect to see the higher you go? You would expect
Well,
to
I
see the
mean, I've
horizon
been
drop, right?
in an airplane, so
Yeah, let's say in an
probably
airplane
similar to that.
that's approximately 10 kilometers. What would you expect to see there?
Well, what I saw was just a shit ton of land until it went out of eyesight where it meets the sky.
Okay. Wouldn't you expect on a spherical Earth that the horizon would be dropping? The higher you go, it would be dropping below your eye level. Right?
I I wouldn't suspect that.
I can show you. I already have it opened. Oh. This one, I think.
But yeah, to be honest, man, I'm not going to be able to be on here much longer.
Okay. Let me just make this point, and then we can quit it for today. It's been 90 minutes anyway. I'm getting tired as well. So, so this is my neat little Earth program that I've also written. The blue circle, that's the surface of the planet. The observer height can be changed in kilometers, in meters, and in millimeters. So what I'm gonna do is I will 200 meters, yeah, whatever. I will set the height in kilometers to 10. So my observer is now 10 kilometers above the surface of the planet. Okay, I set the radius of the Earth to what it actually is, and I've set the height of the target in kilometers to 10. Now, what we can directly see is the red line here. That one represents your eye level. And the green line, that represents the line that's heading towards the horizon. So as you see, and obviously here's the angle between the two. Currently, it's 3.24 degrees. Let me actually change that. By the way, you can read it as well over here. So when I increase the altitude, in this case, it would be 18 kilometers, the horizon drop would be higher. You see now the horizon drop is 4.32 degrees. So what you get is a function that describes the drop of the horizon depending on your altitude.
The
Do
thing
you
is, you're
understand that?
prove to me this stuff on a computer like grafted program, which I already told you I'm not going to accept.
Yeah, then let me make my point and I'll show it to you. You understand that the model is predicting this, right?
According to you.
Okay. So now, how would we go out determining on whether that model is correct?
Say what now? Sorry.
Okay, so what this computer program currently shows is a 2-scale model of the planet. And I predicted that the horizon would actually drop with increasing altitude.
Now, why do you always tell me like oh, you always get on to me for using 2D images, but this is clearly not 3D. This is a 2D.
Yeah, because in this case, 2 dimensions are enough. We don't need the third one.
Why did we need it for me?
Because you were making a claim that involved a 3-dimensional object where a 3-dimensional shape is relevant. In my diagram, all the points are actually in a 2-dimensional plane.
So to see all 4 sides. So
I don't. Here's the thing. All those points in this diagram are in one plane, in one 2-dimensional plane. Therefore, a 3D program would yield exactly the same results, provided all those points would still be in this 2D plane. Therefore, this model is valid. Now, back to my question. I showed you that in this model, there's a correlation between your altitude over the surface of the planet and the horizon drop, the angle between your eye level and the horizon that you see. Now, again, to determine whether this model is correct or not, what would you do?
I mean, I don't know what you would do, but I wouldn't be using that program. I would be outside.
Oh, God. Whether I draw this program in a computer, whether I do this on a piece of paper, doesn't make a difference.
Well, there's no way that the actual real shit we're trying to prove. This can be suited and and like I said, it's based off this. All these programs are based off equations that are theories.
Can you do me a favor and just can you do me a favor and just answer my question for once? How would you determine?
What was the question?
How would you determine whether this model yields correct results? How would you determine this model to be correct, representative of reality?
If you could test it in real life.
Exactly. And how would you do this? I gave you the methodology right here. I described the process from start to finish.
And I don't agree. You didn't. You're not.
Yeah, I did.
You're not correlating this with how it pertains to what were we talking about? Gravity?
No.
Oh no.
We're currently only talking about the shape of the planet.
The curvature. Sorry.
Okay, great.
I
just try to explain it to you. From start to finish. Okay, so this model predicts, the spherical Earth model predicts that the further up you go, the more the horizon will drop to eye level. Now, the way you determine whether this is correct or not is actually that you go up in an airplane, for example, and then directly measure the difference between your eye level and the horizon. When you do that at different altitudes, for example, starting from ground up to 10 or 20 kilometers, which is what I'm doing here with this neat little pulley, lever, whatever thingy. I can simulate this, write the data that I'm getting with the x value, for example, the height in kilometers, and the y value being the angle, into a table, make a neat function out of it, and then try to compare this function that I'm getting to a data set that I'm doing in reality. I could move up a mountain with 1 kilometer altitude, measure the angle, go up 1 kilometer more, measure the angle again, and so on and so forth. And if this model turns out correct, if this model curves
curvature.
Yes, that is exactly what proves curvature.
No.
Why not?
Because, like I've explained several times, nobody can even prove curvature. You can't even see curvature. You're trying to prove something we don't even fucking see, dude.
You can see curvature. I already told you. Do you agree that your eyes have an angular resolution of under 3 degrees?
Sure.
Okay, therefore at 10 kilometers altitude, you can see curvature.
Well, that's not what I believe, man. That's not what I know, because I've seen footage from higher than what they say you see the curvature, and it looked pretty fucking flat still.
Okay, so how often are you in an airplane?
Not very often.
Okay,
Was,
the next time that you get the chance, please do me a favor. Download a theodolite app on your smartphone. Do you know what a theodolite app is?
I'm guessing something that measures the curvature as you're driving along.
No, not necessarily. All it does, it measures the orientation of your smartphone in 3D space. For example, it can tell you whether you're holding your smartphone upside down or if you're tilting it in whatever direction. That's what a theodolite app is for. It uses the internal acceleration sensor of your smartphone. And what you can do with this is point it at the horizon and then tell me what angular value in terms of elevation value it gives out. And that depends on different altitudes. Because you will see when you're at cruising speed at 10 or 11 kilometers, you will get a value of -3 to -4 degrees, which is a direct result from curvature.
Okay, well, I'm pretty sure I've actually seen footage of literally someone filming themselves from I think it was from California. Let's see, San Francisco to Florida, and they filmed the whole thing, and literally you see no curvature whatsoever.
Did you see the horizon drop?
No. Did I see any type of curvature? No.
Did they have an internal reference on which to compare whether the horizon is compared to eye level?
Taking out the fact that, of course, there's different mountains or whatever, valleys and whatnot, changes in land. There's no and another thing, why don't pilots ever account for curvature? Because
are you one of those people that's actually thinking that pilots would have to tilt the aircraft down all the time?
I mean, I don't see why they wouldn't. It doesn't make sense for gravity to be just holding them in. You're saying because it's in the atmosphere that it doesn't have to account for curvature. How?
Okay, so imagine, so an aircraft is at cruising altitudes. It's an equilibrium, right? There are 4 forces that are acting on that aircraft. First of all, there is drag from the wind resistance. Second of all, there's thrust from the engine. Third of all, there's gravity. And fourth of all, there's the lift from the wings. Under cruising conditions, all those 4 forces are in equilibrium. That means that the aircraft will maintain its cruising speed and its cruising altitude. Okay, what happens when the aircraft ascends a little bit?
What are you asking me? When it goes higher?
Yeah, what happens to the 4 forces?
What do you mean what happens to them?
Yeah, what happens to the 4 forces?
The plane?
For example, yeah. Okay, I'll just tell you. When you increase in altitude, you realize that the atmosphere is getting thinner, right?
So they say, yes.
Oh God, no! You can measure that directly. Do you live close to a mountain range?
Humor, you sure? Yes. You okay?
You realize? So you agree with me that
I do agree with that. I've been to the mountains, and yes.
And yes, the air is thinner as you're getting further up, right?
Yep.
Okay. Okay, so when an aircraft ascends in altitude, this means that the air that is surrounding its wings is getting thinner. Now, the updraft, the lift that the aircraft is actually generating with its wings, is directly a function of the amount of air that can flow around it. This means that aircraft have a maximum altitude, right? They cannot ascend over a certain height because the lift that is generated by their wings simply won't be enough anymore. This is, for example, why you need very speedy, very fast aircrafts to reach high altitudes. For example, the Concorde was flying at 20 kilometers or something, and some of the spy planes of the 60s, before they invented nice satellites, reached 35 or something kilometers. Those were supersonic aircraft because you have no other way of reaching those altitudes without either increasing the speed or increasing the size of the wings and making the aircraft idle and so on and so forth. It's getting harder to get further up. Now, the reason that the pilot doesn't need to tilt the aircraft down is when the aircraft is ascending a little bit, the lift will become lower and the aircraft will sink a little bit again. Now, this is not like a step process. This doesn't happen it doesn't like rise a little bit, then sink a little bit, and then rise a little bit, and then sink a little bit again. This will all be in an equilibrium state. That means that when the pilots aren't doing anything, the aircraft will automatically find the altitude in which it's in equilibrium. And this is why pilots don't have to tilt it down. Right, it's a self-regulating process.
Okay, so how fast would you say the Earth is spinning if it's not? Because earlier I said 1,000 miles per hour because that's just what comes up on Google.
15 degrees per hour. Is that true? Yeah, 15 degrees per hour.
Okay, so if I'm not getting how, if you were to take off into flight separate from the Earth, I know you know where I'm going with this because I know you've heard it before. Obviously, if you're independent of the Earth, it would be spinning. Okay, so you have two options, right? You go with the spin or against it. So my question is, obviously you wouldn't go against it because you're going to have to go however fast the Earth is going, and then some to compensate in order to travel faster than it. Now,
yeah, but we don't have to.
I don't see why.
Well,
okay,
you realize that even when let's just imagine you're sitting on the equator, okay? You're sitting on the equator and you're rotating with the equator.
Okay.
Okay. That means you have a certain amount of kinetic energy and you have a certain momentum.
Hold on. So if the Earth is spinning, why wouldn't we just raise up and not even fucking fly off and just hover there and just wait till it spins around and then just touch down?
I'm telling you. Because you have a certain... Because when you're sitting on the equator, you have a certain set of kinetic energy because you're moving along with the planet. Now, in order to brake or to accelerate in any direction, you need a certain amount of energy as well, right? You need a way to push you in any direction. In order to you need to accelerate. You need a force to accelerate you. And when you're not doing that, you will just continue moving in the same direction as you were before, which is in the same direction as the Earth is moving. Are you with me so far?
Yep.
Okay. That means even if you don't have any contact with the planet anymore, you will move in the same direction as the surface of the planet does. This is one of the factors. The other one is obviously you have the atmosphere. You understand that the atmosphere is rotating with the planet, right?
According to your model, yes.
Okay. So
but anyway, man, honestly,
yeah.
I don't think I'm getting my point across either. So, I don't really want waste my time trying to convince people that there's a lot of fucking deception out there, and you need to be more in tune with these fucking higher powers that be. That's all I need to say. So I do appreciate you having me on, man. If we ever do have another one of these, I promise you I will come uh, well prepared.
Okay.
So I will
what I would
study your programs that
do
you
you want
use.
do you want a copy of the files? You would have to download the program itself, though. But it's freeware, so if you want it, you can have them.
Yeah, sure. That'd be
Okay,
awesome.
I'll send them
That'd
to
be
you
awesome.
later in an email. Maybe together with the installer for this. You are running a Windows computer, right?
Yes, I am.
Okay, then I'll send you the entire package later.
Okay, cool, man, cool. And also, you know, it obviously, like, I have nothing personal against you, man. I think you are honestly a good dude. You're a respectable dude, and me personally, I find it kind of insulting that I've learned these certain things just to find out that they're lies. And that's what got me into looking in and doing a lot more research about what's going on. So, that's where I'm at right now. And like I said, it's all love for me, man, for real. Like I have no hard feelings against you. I appreciate you letting me on and giving me the time and everything. And that's pretty much it.
Okay, thanks for joining. If you have any questions regarding the globe model or something, just email me. You know where to reach me.
Yeah, for sure, man. I will do that.
Okay.
Have a good night.
You too.
All right, peace, man.
Peace. Okay, time to invite some people. So let's see. This one. And this one. This one. And actually, the rest of those as well. Etias is in here.
Why do you keep hurting me?
The question is, why do I keep hurting myself?
Yeah, but you don't matter. I'm more important.
What? All right. While you keep the people entertained, I'll be AFK for 5 minutes.
Oh, great! Well, I have someone to talk to, thank God.
Holy fucking hell.
Oh, and you weren't there for the second comic stream.
And I missed a chunk, and I'm like, what the fuck just happened?
Did you know that because if you have something with ferrofluids in it and you put a magnet on it and then you see circles and spirals in it, because you also see circles and spirals in nature, that means that they're caused by the same thing. So magnetism is responsible for everything.
Oh my fucking God.
There is no God, only civil.
Why? I just had a feeling it was going to be a cluster of retardedness as soon as I saw the initial group that was in there. And
yep.
Oh.
Fang fucked you decided to go through his just put his foot down and throw them out.
Oh, that bit was just painful from it. It's like, dude, I want to know how people can say so many words without saying anything.
He mentioned both. First, he said heliosphere.
I am back.
Which, spoiler alert, the heliosphere is like the bubble of plasma around the sun. Like,
yeah, I was about to say heliosphere. What the fuck?
And then he mentioned ecosystem. I don't think he knows what an ecosystem is. Actually, I know he doesn't know that. Like, it's not just.
Wow.
In the beginning, I specifically asked Shinobi not to share the link with anyone. And in total, I had to kick out 1, 2, 3. No, wait. 1, 2,
A lot of people.
3, 4, 5, 6 people. But whatever, that shit
Garrett,
happens.
you're making some kind of weird, like, clicking noise.
Hang on.
I think that's your microphone. Okay, so any questions from the side chat, somebody?
Actually, like, I just want to explain if Shinobi, if you watch this at any point, the reason why you see a lot of spirals and like geometric shapes in nature hasn't got anything to do with magnetism. It has to do with evolution. It's space optimization, basically.
Yeah, the most efficient shape is a sphere.
Just, yeah. Well, that depends on what the efficiency for what. Like, if you're going to store things, like for example, honey in a honey hive, the hexagonal shape is better.
Well, yeah, because they're interlacing, but it's still a flattened off sphere, a flattened off circle.
Yeah, kind of. But like, I was screaming in the chat to get in and try to actually explain this to him.
Do you have the feeling that Shinobi is a lost cause?
Yes. The moment you bring up fucking sacred geometry, you're a lost cause by definition.
That's a good argument.
It's a definition, so it's like there's nothing to argue about.
Well, yeah, okay, that's fair.
The same way that sharing anything from natural news instantly invalidates your argument, even if what you're saying is correct, it automatically becomes wrong because you cited natural news. That's just how the world works. I don't make the rules.
Well, there is a better question in the live chat right now, and it's from NANA. Geo, why? Are you a masochist?
No, not really.
No, he's a sadist. He wants to hurt us. That's why he has to.
No, the reason why I did this was the first hangout I had with Shinobi was not planned by me. That was planned by the Non Sequitur show. And
yeah, we can blame Kyle for that one.
Yeah, and as you might know, the hangout that I had with Shinobi in the first place was unfortunately riddled with technical difficulties. I couldn't share my screen, so explaining things to him was pretty much impossible. So I did this one in order to, first of all, do which I couldn't do back then, and hopefully add a little bit of more of substance to what we were talking about compared to earlier. I was wrong.
I mean, you added substance. He didn't. Well, yeah. Well, he added substance, not to the hangout, but to himself.
Yeah, there were other substances going on.
I mean, one of his friends said that he was, quote, lighting a blunt.
Yep. I mean, fair enough if you want to do that. Like, I don't judge, but like, maybe don't do it if you're gonna have an intellectual conversation.
That reminds me of that Moonloons video by Cold Hard Logic. Quote, let me use that blunt as a ruler. Or let me use the joint as a ruler or something. Yeah. I don't know, as a pointer. Fuck.
I'll admit it, I don't remember that video as well as others.
No, let me use this joint as a pointer.
Yep.
And then he doesn't even really point with it.
Did you notice Shinobi's interesting ability to just deny every refutation
Yes,
about any argument that I was giving to him. That doesn't prove anything. That's just a formula. That's just a computer program.
It's the ultimate argument from nuh-uh.
Argumentum ad nauseam.
This is just a computer program argument. Can we please define that as digital solipsism?
Ooh.
I'm not sure
if that's the correct definition, but I
probably not. But you know what I'm talking about.
Word. And there's actually that brings up that could be a fun sci-fi like Black Mirror like story, like where you're not actually sure, like because you can never be fully sure if the people you're talking to online in a chat room are actually there, are not actually real people, not just AIs.
Do they exist?
Do they exist outside of the computer?
So they tell us. I actually feel bad for the guy, honestly. This is just No, I don't feel bad for the guy. I feel bad for humanity.
Yeah.
Yeah, the people have to live with him. Sorry.
I share a planet with that man.
We all do.
Ugh.
Remember,
Hillel, there's a good chance you don't just share a planet with him, but also you share a country with him. Maybe
you want to
shut up.
A state.
Shut up.
You want to make it even worse. There's a good just statistically, you and him have shared the same atoms.
That doesn't say anything, Micro.
You have stupid atoms in you right now.
Fuck.
As we said, there are 10 million particles in the universe that we can observe. Shinobi's mother took the ugly ones and put them into one dumb nerd.
No. You do not get to call him a nerd. That's an insult to nerdism.
I find that very insulting.
True.
Yes, as a nerd, I find that offensive.
So is it just me, or was his arguments fresh out of 2010?
More like 2005.
Yeah, 5 is probably close up, like
when YouTube was new.
So his arguments are as old as my motorcycle. Nice.
Right, you 10 years
You
old?
just wanted to bring up the motorcycle.
I had to. The door was wide open. I had to walk through.
Did you see the review of the electric one that I sent you?
I did start watching it, and I am intrigued. But again, this is the thing I've noticed with a lot of electric vehicles. They currently, due to range limitations, are impractical for a large portion of the US.
Probably true, yeah. Unfortunately.
No, the US is just impractical. A large portion of the US is just impractical to it. It's the other
how much does electricity cost in the US?
It is variable depending on location.
So here in Germany, we are at approximately 30 cents per kilowatt hour, which means that your 100-kilometer distance in an electric car is approximately worth €5, whether in an internal combustion car of the same size, it's approximately twice the amount. My machine needs about 6.5 liters per 100 kilometers, which translates to pretty much directly €10 per 100 kilometers.
So you just need some bigger, better batteries.
Either bigger or better. I think the solution is not bigger batteries. I think the solution to this is actually a faster charging network. When you have, let's say,
so you stop more frequently. 200
kilowatt charging. Every 200 or every 200 or 300 kilometers, that would mean a stop would only be like 5 minutes or so. You could get used to this, I think.
Yeah.
I mean, Micro, you live in a country that's like the size of a post stamp, so you won't suffer that problem anyway.
I mean, yeah, I can I probably have one stop to get. No, probably have. Let's see, maybe 3 stops to get to the from Copenhagen all the way to Skagen, which is at the top of Denmark.
No, that's one step, maybe two.
No. It's not. Denmark is small, but it's not that small. Like there's at least like 250 kilometers just to get to Jutland.
414 kilometers from Copenhagen to Skagen. That's one tank stop.
I thought you said it was 100, like 100. That the range on the vehicles was
No. I'm saying it would make sense to fuel it every 200 kilometers since you will have to stop. And anyway, the next generation is.
Well, that's what I went from.
That's announced to be approximately 350 kilometers of range for standard versions, until up to 600 for long range versions, which is what I would go for.
Now, you said it was how much per kilowatt hour there?
30 cents. 30 euro cents, approximately.
Yeah, it's about 12 national average for the US, but up in my area, it's closer to 20.
But that's dollar cents, not euro cents.
Yeah.
Yeah, fuck you.
So it's real cents.
Actually, our cents are probably better.
This is just senseless.
Oh. Okay, I got to kick you now, Micro.
Ha, fuck you.
It's 2:30 in the morning. I'm tired.
Yeah, it's 2:30 in the morning and I'm drinking wine directly out of the bottle. What have I become?
I mean, I ate soup at midnight, so...
Hey, that's awesome. I once woke up at 4:30 in the morning, went to my fridge and ate a bunch of leftover spare ribs. And the next morning, I didn't remember that I ate them, so I went there to get them, and they weren't there anymore.
And got disappointed in yourself.
Yeah.
Yeah, I don't have a whole lot of stuff to do. I just have microscopy tomorrow, so that's just 3 hours in a small dark room that smells of oil.
So officially today was my last work day for this year. So and actually for the live chat, this is probably the last hangout of this year of 2018, unless I decide to do one on the 30th or 31st of December, which is when I'll approximately be back from vacation. But otherwise, I think this is a nice finish for the year, right?
You have a strange definition of nice.
Yeah, I was gonna say.
Oh, by the way, Hillel, do you have anything to add to the conversation that I had with Shinobi?
I mean,
just bang your head into the table. That's enough.
Yes, it was just painful on so many levels. It was just bad.
Like I'm fairly certain he somehow he hurt senses he shouldn't be able to hurt me through senses he shouldn't have been able to. Like my proprioception is hurting for somehow.
So, do you want to know the feeling how it feels to communicate with somebody like this?
I already know. I've been in hangouts with flat earthers.
Yeah, but this is a special kind of stupid. Here's the way it feels. Okay, how can I describe this the best? First of all, you feel a stinging in one of your two frontal lobes, and then suddenly the entire world starts tasting like mustard.
You can't actually feel
lobotomy.
pain in your brain, right?
Yeah, fuck you. You know what I mean, Micro.
No, I don't.
So a lobotomy.
Yeah, but at least the lobotomy is done with something sharp. This feels like somebody's just ramming a chopstick into your brain.
It's a non-invasive lobotomy.
No, it's a lobotomy done by spoon.
But what if your spoon is too big?
I hope it's like not a wooden spoon that leaves like.
I'm glad someone got it.
Sharp thingies everywhere in the wound canal.
Wait, did you just say sharp things everywhere in the wood canal?
I said no. I'm worried
Wow.
that a wooden spoon would leave like splinters or something.
I know what you meant. I was going for what you said.
Yeah, fuck you again. I can't brain anymore today. I have the dump, okay?
Oh no, it's contagious.
After dealing with this guy, no, honestly, I'm out. Fuck this.
This wasn't just the last stream of the year. This is the last stream ever. We won't hear from Gio again. He's
No,
done.
trust me, audience, there will be more, and it will be much worse. Because
Why?
I don't know if you should be advertising that.
let me write it in the internal chat so you can see what's gonna happen next.
Oh no. Oh no.
Oh, by the way, everyone, vote for Anthony Riley for Dumb Fuck of the Year.
Yes, I was about to
Oh
say.
my god.
Why? Why, Gio?
The run for Anthony Riley being Dumb Fuck of the Year is still open. So the way this works is you go to Red's channel, and actually, let me just find the link. This is way easier.
I have a link.
Yeah, wait.
There's
I got it. There it is.
Is there a place where we can see all the scores?
So no.
Okay.
So the way you vote for Anthony Riley is you go to the link that I'm just posting right now in the side chat, and then you like the fuck out of that video.
Oh,
For the
dislike.
people in the hangout, there's something
Both.
else, apart from the one that I already posted.
God damn you, Piggy! You haven't fixed the shit on my. Never trust a pig.
No.
So you see the
Gio.
two?
No. Gio.
Which one do you think is worse, the first or the second?
The second.
Are you sure about that? I mean, one is
Yes.
just complete retardation. The other one is
Oh,
overconfident
both
and religious
complete
extremism,
retardation.
I would say.
I'd have to agree with Micah on this one.
So I will say this. While the first one would be slightly more intelligible from a conversation standpoint, I can see the thumbnail for the second one being immensely better.
I've just posted both of them in the side chat. So let's see what the audience says.
I mean, you already have the
Yes, I already have the thumbnail for the second one.
Yes, because we already made a cool one for the first one.
That's true.
And I say I do that because you made the base and I improved it. Oh, Gio, you wanna tell the audience what this hangout has?
Yeah, I already did in the beginning. So this hangout will be called Mental Combat X, and the thumbnail will be a derivation of the
Mortal Kombat
logo for Mortal Kombat X. So yeah.
And our reasoning here is that it's like Shinobi is like a ninja thing. That's literally the reasoning.
So
We didn't put that much thought into it.
So
It is still much more thought than Shinobi puts into
I was
anything.
about to say.
Oh God, he's fallen down a well.
oh god. Well,
Was that
here-
massive?
we do have a good question from Sean Carroll. Shinobi was just said, what is worse?
These two.
You know, actually, I'm not sure if Duran is worse than this.
No, she is. Because at least you have had something that like approached a normal conversation
Yeah.
in this.
He didn't make. A
Yeah,
point.
that's true. I mean, the annoying thing about Debbie is that whenever you would start a sentence, she would just start talking
Oh.
mid-sentence.
Oh,
Exactly.
She has admitted that she does that because she does not want to listen to your answer.
What? When has she said that?
In Gem Panda's Discord on voice chat months ago, she admitted that she interrupts and talks over people because either they do it to her or because she doesn't want to listen to what they have to say.
Oh, for fuck's sake.
Well, it's still gonna be entertaining.
All right, where's my suicide X when I need it?
I mean I did post in the side chat chat, I did post a link to the Amazon page and Razor Blades earlier. So.
Oh, I was wondering why you did that.
No. All right, here's what I need. I need a bigger screw or bolt. I need a wobbly chair, and I need a nice rope.
What is this? A fucking Olsen gang?
No. I'm waiting for him to act like Rocket from Guardians of the Galaxy and say he needs a random person's eye or leg.
Yeah. To be fair, he does need that.
Okay, but I think I'm gonna end this right here and right now.
Well, before you go off air,
okay,
there is something else to advertise because I do
have not be your fucking motorcycle.
No, it's the raffle I'm doing.
Oh yeah,
the what?
Yes, that as well.
The raffle for science. So for those who were unaware, 1, where the fuck have you been? 2, so with International Baller Day coming up on the 31st, I am doing a raffle of my custom flight jacket with the 32 NASA and space-related patches on the 30th, and it will ship out to the winner on the 2nd. I'm actually...
and all you have to do is buy some raffles.
Yeah, it's typical raffle ticket. All proceeds are going to the science department of my son's school, and there's the video.
Yeah, feel free to copy paste that in the side chat.
And there is a link to the video on my channel, the latest video on Fight the Flat Earth's channel. We also talk about it there as well.
How many raffles have been bought at this point? I just want to know my chances.
So number of tickets that I have confirmed is 153, but I have at least another 30 to put down. So we are close to 200 raffle tickets already out in circulation.
All right, and with that, I'm gonna end this right here. We're gonna do this the old rhetoric way. So, Jared, say what you gotta say and then stay, please. But shut the fuck up.
Go take care of the raffle. Trust me, you'll love the patches on the jacket.
Okay, Hillel, your turn.
Kids, don't do flat Earth.
Yeah, I'd rather do drugs. That's probably more sane. Micro.
As I said, I posted the link for the razor blades earlier. You can scroll up or just Google razor blades. And remember, it's down the street, not across it.
You know what, Micro? The link to the razor blades will actually end in the video description. So
good.
Yeah. So I guess that's it for the year. Thank you very much for watching this year's season of GeoStreber or something. See you next year. Have a nice Christmas or Hanukkah or Kwanzaa or whatever the fuck doesn't offend you. Have a nice New Year's evening. Don't drink too much. Or actually, drink too much. Drink a lot. Go ahead. Fuck it. You only live once, you know?
Live a little.
But don't accidentally lit the church on fire. That's not a good thing to do.
Nah.
And see you in the beginning of January. Hopefully. I don't know. I'll try. I can't promise it. We will see. Oh, and if you want a personal tip for watching a good show over the holiday season, I would recommend watching The Sopranos because